Well, thanks, Kate and Christy. So I'm going to be the first of a series of three that will go through three different components of the knowledge base that you just heard about. So I'm going to kick off. I will give a little bit, maybe some overlap with what you just heard, but I'll give a little bit of background on AOPs, a little bit of background on the knowledge base, and then talk about the Wiki. And then Ed will be covering the Explorer, and Hristo will be covering the Effectopedia. So, and just to kind of set things up, so at least the way I view AOPs is really as a bridge. So on one bank, we've got TOX21, TOXCAST, SURAT, all of these efforts where we're trying to move things to in vitro. On the other side, you've got regulatory decisions that necessarily need to be done at an organism or population level. And so I really look at AOPs as a means for bridging that gap. And so this is just, again, you've seen this already, but thinking about the idea of toxicity pathways as they were defined in the 2007 NRC report and the regulatory endpoints. And then basically what you're doing is you're providing a series of steps along the way to help describe how a perturbation that you might see in an in vitro assay would relate to something at the organism or population level. I'll go briefly through kind of some three overlapping steps: developing the AOP, evaluating the AOP, quantitative description of the AOP, and then once you have it, what do you do with it? And I'm going to do that to set that up, because then I'm going to work through an example in the Wiki where we kind of show all of those steps. So just as a way of background, AOPs are actually pretty simple. They really only have two main components. They have key events and key event relationships. So the key events are the nodes, and they represent a change in biological state. Because we want to actually be able to make measurements and determine temporality of the key events and also get quantitative relationships between them. We want them to be measurable, or at least a good surrogate biomarker to be available. And then we have two special key events. One is the molecular initiating event, which is that's the biological entity that directly interacts with the chemical. And the adverse outcome, again, would be something at the organism or population level, which has a regulatory significance. One thing to note is that the AOP itself is chemical agnostic. And again, if you think about the goal, that is to relate an in vitro assay that we can run for thousands of chemicals to an adverse outcome. If you enter into the AOP itself chemical-specific information, you can't now generalize to thousands of chemicals. So for the development and the defining of the AOP, you don't have chemicals. In the use of AOP, you obviously do have chemicals, and you have a lot of chemical-related issues that you need to consider. As was mentioned, there was a series of workshops, and the first workshop was actually in March of last year. And coming out of that workshop, there's been a series of papers that either have been published or are soon to be published. And so I have them listed here, but you don't need to take them all down. If you get the URL at the bottom, that actually is, we keep a running list of the current state of all the papers. So if you go to that URL, you'll have links to all the papers that have been published. And when the other papers are published, we will be updating it to include links to there as well. And so if you're interested in more information on any of these steps, those are the papers. And then when we move into the use, that is where we pull in the chemical information. And again, there's a couple of papers. This Perkins paper is the same one that's on the previous slide, so they kind of cover both the quantitative description and the use in that paper. And then there's also the Tollison paper. Actually, it just goes more into an IATA type approach. So when you actually go into the use, the AOP is reduced down to a simple linear pathway for convenience and for making it a more defined problem when you're going to develop it, but we all understand that biology is a lot more complex than that. And so we have designed the knowledge base in such a way that when you go to use the AOP, you can actually think about it in the context of not just that single AOP, but also any other connected AOPs that might be in the network. And that's where Ed's tool comes in quite handy. We must incorporate chemical properties, including exposure and ADME. And to give a shameless plug for a session that I'm chairing tomorrow, down at the bottom, we'll actually have a session tomorrow morning that discusses that very issue. You also need to consider modifying factors such as genetics, pre-existing disease, and again, those kind of fall out of the AOP networks. So the knowledge base was really developed to help facilitate both the development and the use of the AOPs. And it was built as a series of individual components. So the AOP Wiki, which I will talk about in more detail, is really intended more as the first stage. So we capture a textual description of the AOP. We are very tightly coupled with the OECD handbook, as I'll show you in a moment. And so it's really kind of the first step. And this is a joint project between the European Commission and the Joint Research Center and the EPA. And Effectopedia, which is being run out of the OECD, really starts to take that information and structure it much more. So whereas the AOP Wiki has minimal structure, it mostly boils down to those two components that I talked about earlier. Effectopedia really captures much more information about what the assays are, the quantitative information that goes into it, and you'll hear more about that from Hristo. The intermediate effects database is captures more regulatory related information, and it's actually going to be implemented in the Euclid 6 release, which is the next one that's coming out in the fall. And the AOP Explorer is a mechanism to allow users to look at the AOPs in that network context that I was talking about earlier, and Ed will talk about that momentarily. And then we're developing an AOP-KB hub, which is going to facilitate the communication back and forth among all of the individual components. And once we have it, we intend to make that API available so that if other people want to make third-party tools that connect to the AOP-KB, they will be able to do so. And I think I went through all of this earlier when I was talking about the wiki. So we'll just go through quickly. So as I mentioned before, the wiki really breaks it into two main components, key events and key event relationships. We do classify MIEs and AOs. Now we classify MIEs and AOs in the context of a specific AOP. And that is because a key event might be a molecular initiating event in one circumstance, but a downstream key event in another. The best example I can think of will be the aromatase example that we're showing, where downstream of aromatase inhibition, you have changes in estrogen receptor signaling. If you have a direct estrogen receptor agonist, it's going to be a molecular initiating event. And then the key event relationships are really where a lot of the weight of evidence that Betty's going to talk about is captured, because that is where we define how the upstream key event triggers the downstream key event and what evidence we have to support that assertion. And even though the chemical is not part of the AOP itself, we do capture chemical information in the knowledge base, and we're actually, one of the purposes for the workshop tomorrow is we're actually looking to build out more features, and Effectopedia is going to have more features in the future to better handle the chemical information. As I mentioned earlier, the wiki matches the OECD guidance and handbook. So if you were to read through the guidance and the handbook, it talks about summarizing your AOP and then certain information that's needed about your molecular initiating event, your key events, your adverse outcome. And the way the wiki is structured, this information gets put on separate pages, and the reason for that is reuse. So once you've defined a key event, you don't define it again. You just simply link the next AOP to that same key event page. That serves two purposes. One, that means everyone who knows about that particular piece of biology can contribute to one document as opposed to having multiple key events. But it also is critical for the networking component of the knowledge base, because if you have two AOPs pointing to the same key event, we know that those two are connected in the broader network. We also have the key event relationship pages are separate, and again, that's for reuse. The other information goes on the AOP page itself. And so the AOP page in the wiki is kind of this mix of structured content and free text. So you can see the structured content in blue, though all of that information is entered through little web forms. And then the free text, you just click on an edit button and you add that in the free text. So you'll hear about shortly aromatase inhibition as one of the case studies. And so this is the AOP as it's structured, as it's saved into the wiki. This was Dan Villeneuve out of the US EPA's Mid-Continent Ecology Division put this in. We have the OECD project that this was developed under, and some information about when it was last updated. Within that summary section, we have a table for the molecular initiating event, table for the key events, and the adverse outcome. And if we were to follow those links to the pages, we would get biological descriptions of those key events, the methods that can be used to measure those key events. If it's a molecular initiating event, we do have a list of the chemicals that perturb. Actually, we have a list of the chemical initiators that perturb the key events, and chemical initiators are simply there to capture exposure in ADME components. And then on the adverse outcome pages, we'll have an optional section for describing the regulatory context for that adverse outcome. You'll see in the tables for the molecular initiating event and the key events, there's a column support for essentiality. The textual support behind those assertions is further down in the AOP page. And the criteria for defining moderate, weak, and strong in that particular case is outlined in the handbook, and Betty will cover that in her talk. The key event relationships, so we have those listed next in that summary section. And again, if we were to follow the links to that particular page, we would find textual descriptions describing the biological plausibility for the upstream key event leading to the downstream key event. We would find information about the empirical support for each pair of key events. Once you have that information tabulated, again, the OECD handbook provides some criteria for what you would then put in that weight of evidence column as far as strong, moderate, weak. There's also on the key event relationship page a textual description about the quantitative understanding of the relationship. And again, there's criteria for what you would then rate that based on what the level of information is. We do provide a graphical view of the AOP, and kind of the goal for any individual AOP is to have it look like this at the end. Again, it's a linear series of events. You might have some indirect edges that would curl out around this, but you don't want a lot of branching and splitting in an ideal world for a single AOP. And then in this case, it's just giving a view of a single AOP, but the AOP Explorer that Ed will describe will talk about that in a broader context. At the bottom of the AOP page itself is an overall assessment of the AOP. So you give a weight of evidence summary. Again, most of the details are on the key event relationship pages, but you give a short summary there to basically support the calls you made in the table above. Essentiality of the key events. Since those calls are made in the context of a specific AOP, that information goes originally on the AOP page itself. And then the quantitative considerations, as I mentioned, is really a textual description of the state of knowledge. We don't capture quantitative information in the wiki. That information goes in Effectopedia. We also have tables that will allow you to define the applicability domains, whether it's life stage, species, or sex. Those are up in that summary section, but then there's text sections down at the bottom where you can justify those calls. And then once you have the information in the wiki, we're working on mechanisms whereby then you can create a snapshot, which would create a printed document that would follow the OECD handbook. And this is actually how at least the OECD process is going to work, in that they will review one of these frozen snapshots so that the information content in the wiki is not having to be frozen. So the goal for the wiki is it will be a dynamic, continually updating source. We'll always have the latest information. And then what we will do is periodically, if a governing body wants to endorse an AOP, they will pull out a snapshot, and that's what they will endorse. And we're working on some features so that you can quickly determine what the differences are between any given snapshot and the AOP itself. So basically what it's saying is that the OECD development program has 29 or so projects related to AOP development, and 6 or 7 that are case studies. And a case study actually works through not just the AOP development, but also chemical specific uses of those AOPs. So that's what those numbers would be in that second row. But realistically, there's only one reviewed and approved AOP, and that is the one for skin sensitization. That has been endorsed by the OECD. It is being used, and that's it. However, we have quite a few that are moving along, and if anything, I think the pace is actually ramping up. So right now we have 11 AOPs from 8 of those projects that are being reviewed by the Extended Advisory Group for Molecular Screening and Toxicogenomics, which is the OECD body that's kind of overseeing the AOP development program. There's 4 more that are scheduled for review, and they should be in there shortly. If you go to the AOP wiki, there's a link on the left-hand side that says AOP list. If you click that link, all of those AOPs will show up at the top of the page. It will tell you these things are under ECMAS review, and you can look at those AOPs. And actually, anyone can comment on any of those AOPs. In addition to the 11 that are under review, there's 14 total, so an additional 3 are open for public comments, even though they haven't been submitted for review yet. And then there's 44 AOPs under development. So they're available for viewing, but the authors have stated that they're not quite done yet, so they want to hold comments until they finish. However, some of these are not currently under active development, though they are looking for a home. So if you find one and would like to adopt it, let us know, and we would be very happy for that.